Hello, wonderful physics students. So today we are going to go over a sample projectile motion problem. And the purpose of this video is to step you through the steps that you should take for every projectile motion problem and show you how they apply to this particular example. Okay, so let's get started. In this example, a diver springs upward from a board that is 3 meters above the water. At the instant she contacts the water, her speed is 9 meters per second, and her body makes an angle of 75 degrees with respect to the horizontal surface of the water. Our goal is to determine her initial velocity, magnitude, and direction. Okay, so for the first thing that you want to do for every projectile motion problem is to draw a picture. So in this case, the board is 3 meters above the surface of the water. The diver is going to jump upward, so she's going to go up before gravity pulls her back down towards the water. And we're given that she is traveling at a velocity of 9 meters per second when she hits the water, and the angle that her velocity makes with the water is 75 degrees. Our goal over here is to solve for the initial velocity of the diver. And we're given, or we know, that gravity is approximately 10 meters per second squared down. You can use 9.8 or 10. In this example, I will use 10. The next step we do is we're going to write down our givens. And since we're doing projectile motion, we will have an x part, or the x direction, and the y part, the y direction. You need both because the acceleration in the x is not the same as the acceleration in the y. And then we fill in things that we know. So we know that the acceleration in the x is 0 meters per second squared, and the acceleration in the y direction is negative 10 meters per second squared. We're taking the positive y direction as up, and the negative y direction is down, so the acceleration in the y direction will be negative. Now this is a template you can use for any projectile motion problem because this will always be true for anything falling through air close to the Earth's surface. Also notice that the initial and the velocity in the x and the final velocity in the x will always be equal. So these two numbers right here will always be equal because the velocity in the x direction does not change. Which means that the only equation you will need in the x direction is v equals change in x over change in time. It's the only equation you will ever need in the x direction because there is no acceleration in the x direction. All right, so we're given a couple other things. We're given this 3 meters. Now notice this change in y is our y displacement, not the distance traveled. The diver goes up and comes back down, but for our change in y, we are only concerned with the displacement. So the diver actually, from beginning to end, falls 3 meters. So we're going to put a negative 3. The negative means that she landed below where she started, and the 3 meters. So there we go. The other thing that we're given is this 9 meters per second at 75 degrees with respect to the horizontal. So whenever we have velocities at an angle, we have to find the components, the x and y components. So we use the sine, cosines, and tangents. And the velocity final in the x direction is 9 meters per second times cosine 75 degrees, and in the y direction is negative 9 meters per second times sine 75 degrees. Again, the negative denotes our direction. So we do that, we get 2.3 and negative 8.7. Since the initial and the final velocities in the x direction are equal, we can go ahead and we could solve or just state that the initial velocity in the x direction is equal to the final velocity in the x direction. So now we have one of our components for our initial triangle, which is great. So now we just have to solve for our initial velocity in the y direction. So we use our kinematics and the y part, and so we want the initial velocity in the y direction. We don't care about change in time at this point, so we use the kinematic equation that does not have time. Vf squared equals Vi squared plus 2a change in y. And we do this for the y direction. We plug in our numbers and chug out an answer. So we get approximately 4. So initial velocity in the y direction is approximately 4 meters per second. So how do we write our final answers? So if you see here, we have the initial in the x and the initial in the y. We can write it in vector notation. So we have v initial, v naught, v at time 0, equals v initial in the x plus v initial in the y, meters per second. I hat is the unit vector in the x direction, j hat is the unit vector in the y direction, so we could just plug those numbers in, and this is perfectly acceptable for your final answer. Or you can go to your original triangle, so v initial, v naught, and draw your components. We have our components. We have the x, initial in the x and the initial in the y. You use Pythagorean theorem to solve for the hypotenuse and tangent, arctangent, to get your angle. And you could write this out. The bottom part, v naught equals 4.61 meters per second, and theta is approximately 60 degrees, and that will be acceptable as well. I hope this helped. See you later.